Hello wonderful person and rejoice Star Trek fans. The warp drive might be possible after all. Today we're discussing a really intriguing and potentially groundbreaking study from a very famous NASA scientist who potentially and somewhat accidentally discovered what seems to be a warp bubble. That bubble you see formed around this hypothetical spaceship traveling across the galaxy that's allowing it to travel way faster than the speed of light. With this particular type of an engine and this type of a device, sometimes referred to as the Alcubierre Drive. The hypothetical way for us to travel faster than the speed of light by essentially warping the space-time around the craft and allowing the craft to travel at normal speed inside the bubble, with the bubble itself then sort of allowing it to travel way faster than light. The concept that we've discussed in many of the previous older videos, but we're going to briefly discuss it here as well. And so let's discuss a little bit more about what's happening in this study, but more importantly, what all of this means for us right now, and if we're actually going to be able to build these faster than light travel engines. And so the idea behind this drive and the idea behind the way we can actually travel faster than light without breaking any physics was originally proposed in early 90s by the Mexican theoretical physicist whose tiny picture you see right here, Miguel Alcubierre. Anyway, his proposition was actually pretty sound. It did not break any physics, and a lot of scientists got really excited about his propositions, except for one little fact. It required some really strange type of exotic matter and energy that just didn't really exist. Or at least we didn't really believe it was possible, and it didn't really exist back then. With a lot of this also requiring a tremendous amount of energy that would basically require something that's equivalent to the size of Jupiter in mass in order to produce all of this energy for just a tiny craft to travel. But then eventually some of the other scientists, including NASA's brilliant Harold White, proposed some of the reworked ideas here where things kind of started to make a little bit more sense. A little bit less energy was required, but the actual premise of this negative energy was still not something we could produce very easily, with the main premise still being relatively the same. You essentially have some sort of a device that combines Einstein's field equation to create a kind of a space-time region around the central object, where the space in front of the craft is contracted and the space behind the craft is expanded, which then in effect allows the spacecraft to travel faster than the speed of light. Inside the bubble, it's traveling at a regular speed. Outside of the bubble, it appears to travel much faster than the speed of light. This is essentially the premise behind Star Trek's warp travel. And although mathematically, and according to Einstein's theories, this sort of made sense, it still resulted in requirements that were not actually physically possible, specifically negative energy. And so some of the scientists back in the days, a few decades ago, proposed that maybe there is a way to create some of this energy by using some of the ideas from quantum physics. For example, there's this very famous experiment that produces what's known as the Casimir effect. So let's just say you take two very thin plates and put them extremely close to one another. Here's actually a picture from the paper of some of these plates produced in this particular study. And then you put these plates in complete vacuum, whereas there should be nothing interacting with them. Well, logically we would assume nothing would happen to them. But in reality what ends up happening is that they actually start receiving pressure from the quantum physics effects. And the way that this is usually explained is by using the ideas behind quantum fluctuations. And that's of course the concept behind things like Hawking radiation, where a lot of virtual particles are always produced even in complete vacuum and are then, assuming nothing else happens, disappear just like that. But the thing is, even though a lot of quantum fluctuation happens on the outside of these plates, but in between these plates, where there's very little space, this actually causes the fluctuations to change. Only an extremely small amount of fluctuations will happen, and only a very small amount of these particles will be produced. And because of this, there's actually a pressure from the outside because there's more virtual particles on the outside than there is inside. That's basically the ideas behind pressure when it comes to gases. And though it might sound like science fiction, this actually has been tested many times and seems to actually work. There's definitely pressure on these thin plates. And today we refer to this as Casimir effect, with the actual effect on the inside sometimes referred to as Casimir density or Casimir negative energy. And this effect has been actually very widely studied because we still really want to learn more about it and we want to understand the actual effects and potential applications. Which is, to some extent, exactly what the scientists in this paper were doing, and we're actually studying this using some of the funding from DARPA, from the Defense Department, with the wonderful NASA's Harold White basically being the main researcher behind the study. Now this person you might have heard of before. He's essentially the person who reworked Alcubierre's original propositions and made them slightly better. He's also the person that designed several experiments trying to test the EM drive back in the days, and he's essentially at the forefront at NASA trying to explore these alternative ideas of space travel and alternative ideas for energy. And back in 2019, White and several other scientists and astronauts started this non-profit organization known as Limitless Space Institute, with the main purpose of the institute being exploring these ideas and trying to study them scientifically, trying to see if we can actually maybe one day create some kind of a faster-than-light travel device or something else entirely. I mean, this is their website, you can actually find it in the description below, and the website itself sort of shows you exactly what they're planning to do, or at least are trying to do. But all of this is of course still in its infancy. And so back in the days, a few scientists sort of thought that, well, maybe Casimir effect could be a way for us to create some of this negative energy, which could then be somehow used in these warp drives. That was an interesting proposition, of course, but obviously nobody knew how to go about it, or where to start looking for this negative energy, or if it's ever going to be possible at all. Now, in the last few years, a few studies have actually proposed several other ideas on how this could be done. For example, in some of the studies, scientists proposed using extremely massive spaceships, basically mass of a planet, to try to create various dilation effects on the inside, which in essence would have a very similar effect to traveling faster than light. Some other scientists proposed adding various types of wave interactions in order to stabilize the bubble and make the energy requirements much less. But the thing about these particular propositions is that they were very theoretical, and they actually added even more mystery and more unusual effects and unusual scenarios which we can't really achieve physically. For example, how do you build a spacecraft that's essentially a mass of Jupiter? And that's of course not super realistic. These theories are of course interesting and great to read about, but they're currently in the realm of science fiction. And then we come to the study that we're talking about today. So first of all, the study itself had nothing really to do with any faster-than-light travel, with warp drives, or any technology that's sort of Star Trek in a sense. It basically was studying the Casimir effect and trying to identify various new effects that could potentially be detected between these plates and potentially be created if various shapes were used inside those plates. And, completely by accident, the person who was always talking about warp drives seems to have discovered something that he was always meant to discover. Dr. White, the main researcher behind this paper, completely by accident discovered that some of these plates were producing an actual representation of energy density that seems to be very similar to the original predictions of the Alcubierre warp metric, or basically that negative energy that was always required in those formula that were previously believed to be impossible. But here it's very important to clarify that this did not actually produce a physical warp bubble. It was just a theoretical paper, and it was using a numerical calculation to come up with a model of what they think may work. On top of this, Casimir effect by itself isn't the same as warp effect. It could be used to maybe produce these effects, but at the moment it's not really known. Nevertheless, these preliminary calculations suggest that using this technique, it could be possible to not just produce Casimir effects, but an actual real warp bubble. Something that you see simulated right here in Space Engine. But there's a small caveat. It's super tiny. It's like really tiny, nanoscale. But every major discovery usually starts small. And so based on this particular discovery, there is now maybe hope for something a little bit bigger, something that might fit a spacecraft. As a matter of fact, these discoveries using the Casimir effect might even allow us to create something a lot more exciting than the warp drive. By studying the effects inside these nanocavities, the scientists like Dr. White are actually hoping to discover some new effects that could potentially transform our society in some other way as well. Something that we can't even imagine right now. But obviously, baby steps. We have to take it slow. So what's next for the Limitless Space Institute, and what are their actual experiments going to be in the next few years? Well, first of all, they're planning to create some sort of a model to see if this actually can be recreated using a tiny miniature, well, spacecraft. Or basically just a model spacecraft. They're planning to create a tiny sphere, probably only 1 micron in size, and then insert it into a 4 micron diameter cylinder to try to see if these effects can be recreated using an actual model. It hasn't been done yet, but they're planning to use a nanoscale 3D printer to try to create all of this and to then test it in physical conditions. And so the first step here is to try to explore these warp bubbles in really miniature conditions in nanoscales and micron scales. And if it all works in these small conditions, they're going to start trying this in slightly bigger conditions and hopefully figure out how all of this actually works. So definitely a pretty exciting project. But now we come to the but. Well, let's talk about the problems. Okay, first of all, we know that Casimir effect is still not really well understood. As a matter of fact, there is still a chance that in their experiment, they were maybe detecting something that can be explained in some other way. Remember the EM drive? There was a video I made about this a few months ago that essentially proved that EM drive was actually just a mistake based on the folding and the bending of material. You can find this video somewhere right there. In other words, EM drive was never actually a real physical drive. The actual pressure inside the EM drive was caused by something entirely different. On the other hand, the bigger problem here is, once again, theoretical. At the moment, the idea behind the warp drive is actually based on Einsteinian principles. But the idea behind negative energy is coming from quantum physics. These two theories currently do not really have a very good connection. In the past, scientists have proposed that a quantum gravity theory might actually help us explain everything in the universe, but that theory doesn't exist just yet. And so, a lot of scientists today believe that maybe, just maybe, Alcubierre Drive is actually not physically possible because it just combines ideas from two theories that do not actually have a connection. And although it could hypothetically exist if one day we discover quantum gravity theory and are able to re-explain all of this using that idea, at the moment it's just not really sound. I mean, a lot of scientists still think it's possible, but some other scientists believe that connecting these two ideas is not really prudent. In other words, what I'm trying to tell you is that you should probably subscribe, because I'm going to be talking about this in many other videos in the future, so make sure not to miss them. On this note, well, check out the paper in the description below. Thank you for watching. Maybe share this video with someone who loves learning about space and sciences, and maybe support this channel on Patreon by joining channel membership or by buying the Wonderful Person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye. Although I guess I should have ended this one with live long and prosper.